Hello everyone, my name is 𝗦𝗲𝗀𝗀𝗀. I'm the regional manager for a product called 𝗦𝗽𝗀297 from Zoho Corporation. We'll be discussing about AI-infused DevOps monitoring, a winning combination today. So let me take you to the session with a scenario that we are facing day to day. So everything is digitized, as you see in this image. We are not waiting for the taxis anymore. We are not waiting in the line to book a ticket at the theater, or not even arguing with the front desk at the hotel to get a deal. We do everything with our handheld devices or mobile phones through applications. It's important to monitor these applications, and more important to monitor the performance of these applications. So we are going to see how to do a monitoring or observability for your DevOps day to day. So this is a familiar term that we are getting, that we are seeing every day: observability over monitoring. So monitoring seems to be legacy nowadays. So it's important to monitor the availability. It's more important to monitor the performance. So what does this observability do and how it is built? Observability is built over monitoring and analysis. Yes, it is important to monitor the availability, and it's always important to analyze the performance of an application or a server or any tools that you're using in your DevOps. So let's say how this observability is built on. What are the three pillars of observability? The first one is the metrics. The second one is the traces. And the third one are logs. So what is the metrics and how it is used in DevOps? Metrics are built, or metrics can be classified into two types. One is the availability and the other one is the performance. Let's say an example of a website. So you wanted to know that your website or web application is available to your customers all the time. So how the monitoring is done? Your server will be sending a HTTP request or HTTP request if it is an older one to make sure the website is available. If the server receives a 200 response code, it will be classified as up. But if it is receiving a response code other than 200, then the website will be declared as down. So this is pure availability monitoring. It will tell you whether your website is available to your end customers or not, but it will not tell you the performance. Here, the performance I'm talking about the slowness. So if your website takes a longer time to load, or if your website's throwing a different web page, then you will be losing your customers. So to monitor the performance, it's always, here in this case, it's always important to monitor the response times. So the metrics that are involved in this response time are DNS time, connection time, first byte time, last byte time, and so on. For an example, if the DNS time is more, or if it is spiked up due to the public DNS, then you should be working on your DNS time. So this is what the observability tool brings in. It brings in more performance metrics than just the availability. So not only website monitoring, let's take an example of server monitoring. In DevOps environment, you will be having servers of different operating system, be it Windows or Linux or Mac OS X or FreeBSD. So it is not only important to monitor the availability, whether your server is 100% available or it is down. You have hundreds of metrics that needs to be monitored from your server. So this one will give you a clear example on how a monitoring tool differs from observability tool. A monitoring tool will tell you whether a server is available or not, or in some cases, it may also tell what made your server to go down. Let's say the CPU spiked. But the observability tool differs from the monitoring tool here. It will tell you which process or which service spiked the performance of your CPU. It doesn't stop with that. It will also help you to correct the problem where it occurs through IT automation. Let's say you are running a script by setting a threshold. let me give you an example that you're monitoring your server and you have your IaaS application running on it. If the CPU utilization of your server been spiked by the IaaS services, then a monitoring tool will tell you that the CPU has spiked, and you will be taking an RDP or remote session into your server, and you will find, you'll open the task manager and you will find the IaaS service to be eating the CPU utilization. Then you will be killing the service and you'll be doing the corrective action. It all involves manual intervention. But an observability tool will allow you to do the IT automation on its own. So here you will be running a server script by setting a threshold for the IaaS service, let's say 85%. So if the 85% of the CPU utilization has been spiked due to the IaaS service, then the script will kill the IaaS service and it will restart the service as well. So there is no manual intervention involved in this case. So right after completing all this IT automation, notification, executing the action, and sending you the up notification, you'll be receiving a root cause analysis. The root cause analysis will tell you what are the factors that has affected the performance of the CPU. So that's how an observability tool differs from the monitoring tool. And in the DevOps environment, you'll also be able to do the network monitoring. Here again, the metrics involves different network attributes using performance counters, not only CPU, memory, disk utilization of the network devices. It will also tell you the VPN connection, the tunnel availability, the fan usage, and so on. And compared to server monitoring, network monitoring involves more metrics, and you will be able to do tons of metrics monitoring and observability using an observability tool. And what is the usage of traces when it comes to observability? So here you can monitor the performance of your application using the traces like Node.js, .NET, PHP, Ruby on Rails, whatever the application may be. You will be able to monitor each and every transaction that happens at the backend, and you'll also be able to monitor the traces that's been involved. So you know what are the error traces, and through the error traces, you'll be able to get into the stack trace details, and you'll be able to figure out which factor has affected the performance of this particular transaction, be it the response time or the throughput. You'll be able to identify them instantly, and you'll be able to correct them as well. And learning all these data will help you to build a complete observability tool with the help of log analysis. This will also help you to build the AI engine of your observability tool as well. We'll be seeing how it works here. So the tool will consolidate every log that's been captured. So if you take the website monitoring, it captures the log of the DNS time, the connection time, the response time of the website. Or if it is a server monitoring, it will be collecting the logs of CPU, memory, disk utilization, buffer statistics, and so on. Or if it is a network monitoring, it collects the logs of the network consumption, the bandwidth usage, the CPU utilization of your server, of your network devices, and so on. And this one will help you to do the log analysis across all your server, not only the server that we are talking about, like Windows or Linux server. It will also help you to do the log analysis across your application servers, like IaaS, Access Log, Apache Logs, Tomcat, and so on. So if you combine this observability with AI, you will get a sophisticated tool that will help you to avoid manual intervention at every step. So before that, let's learn what is machine learning and deep learning. What is the difference between machine learning and deep learning when it comes to artificial intelligence? As this example states, machine learning is something which learns on the high level, whereas the deep learning will help you to learn each and every attribute involved in a system. So here, The machine learning will help you to understand whether the sound that comes from an animal is a cat or not. So it will not tell you whether it is a dog or whether it is a rat or tiger or anything. This tool, the tool which has the capability of doing only the machine learning will understand only the cat because it was made to understand only about the cat. But the same tool, if it has the deep learning capability about learning all the animals or the different breeds of cats, it will be able to identify not only by the sound, by its eyes and by its touch, it will be able to learn about the behavior of the cat, and it will tell you which breed it is and what type of cat it is and from which country it is and so on. To understand more, here you're seeing another example of the vacuum cleaner. So the traditional machine learning is like using the vacuum cleaner to clean your home with manual intervention. So you'll be switching on the regular rollover. You'll be using it across your home, and you need to do that. And it'll clean the home, and you have to collect the dust and you have to throw it away. But the intelligent deep learning that we are currently using in our robotic vacuum cleaner will allow the vacuum cleaner with your command. Will allow the vacuum cleaner to work on with your command. So you can simply ask the vacuum cleaner to clean your home. It will learn the layout of your home, the blueprint of your house, and it will understand it right from the next cleaning. It will understand the staircase, it will understand the walls, and it will move along with what it has learned deeply. So it cleaned the home, it clears the dust, and it will connect back itself to the charger. So that is the major difference between the traditional machine learning and the intelligent deep learning. A tool should be capable of doing this deep learning. A tool like 𝗦𝗽297 does this smart insight of every operation that it does. It learns the data what it collects periodically. So we learn the data, for example, for the first 4 weeks of the inception of the monitor. Then we'll learn this data periodically. For example, if the CPU utilization of your server is 65% every day, based on its learning, it will be able to set a base value. So whenever there is a spike more than the 65%, it will be able to give you a likely anomaly or confirmed anomaly about the performance of your server. And this 65% of CPU utilization doesn't stop there. It learns the performance of the server periodically. If the performance of the server changes after a week or after a month, after a quarter, to 70%, or it gets reduced to 50%, it will be able to understand that the performance there is a change in the performance of the server, and it will be able to alter this base value to the higher or the lower based on its performance. From there, if there is any spike, it will be able to notify you as well. On top of this, it will be able to do the IT automation and do the anomaly that we have discussed, like confirmed anomaly, or not only the server, even for website monitoring. If there is a DNS spike or if there is a response time spike, it will be able to understand and notify you accordingly. And IT automation is pure orchestration. As I gave you an example of the CPU spike of IaaS application, or it can be, you can restart the service, or if you want to run a script, or if you want to reboot the server, the IT automation will work based on the threshold that you set. And even if you miss to set the threshold, the anomaly detection will help you to set the base value based on which the IT automation can also be executed. So 𝗦297 is a tool which is capable of doing the DevOps monitoring. And it's moreover an all-in-one platform. It helps you to monitor the performance of your website, the server, the cloud servers like Azure, Amazon Web Services, Google Cloud Platform. It gives you a complete network monitoring, starting from interface level monitoring to NetFlow Analyzer, Configuration Manager. And it helps you to monitor the performance of your application through Application Performance Insight. So you can monitor your Java, .NET, PHP, Ruby on Rails application. The real user monitoring will help you to understand the user's experience on your web page in real time. And obviously, the app log analysis will help you to understand the complete log of your entire IT infrastructure. It'll analyze it, and it'll also notify based on the threshold that you set. Since it's a cloud-based monitoring tool, we follow all the security practices like a SOC 2 certification, GDPR compliance, not only for the European Union, for every data center that we have. I mean, we have 5 different data centers, primary and recovery for US, for European region, India, Australia, and China. So we are a tool from Zoho. We are a tool under Manage Engine, a Manage Engine which gives you different tools like SDP on demand, Active Directory. Site 24/7 is a cloud version of Manage Engine. And we are a product of Zoho. That's all from the session. I believe the session was informative. Thank you. Have a good day. Bye-bye.